So,
All right.
thank you so much, Rob.
Thanks, Richard. And thanks for coming out. I was asked to give a talk, and I thought, well, there's the things that I like to talk about are technology. And so what I thought I would do is focus on some of the new planning tools that are out now and that will be much more commonplace in the very near future. Talk a little bit about some visualization tools, and I wanted to have kind of a roundtable discussion on autonomous vehicles because I think it's going to have a huge impact on our professions, particularly Rob in transit. And so,
I'm in parks now.
Oh, you're in the parks?
Yeah.
I can't keep track.
Come back to the green side.
Welcome back to the fold.
That's
Anyway. So in terms of planning tools, we've all been involved with drones, but as that's starting to evolve into machine learning, multispectral satellites, and even smartphone applications. So I'm going to take you through some of those. So the drone, this is a Phantom 4. These things used to be very expensive. This is about $1,700 nowadays. It's got LiDAR built right into the front, and it's just used for collision detection, so it doesn't scan things yet. The new drones will. There's LiDAR on the bottom as well, so you can fly it around and not collide with things. So that's one of the big differences from the older drone types. And one of the things that I like to use it for, beyond just kind of getting nice aerial shots, it's actually a great tool for social engagement. So this was, I think it was Tuesday night, we were out in Musquodoboit Harbor, we're working on a plan there. And we, doing walkabouts with the community, we use the drone, we put it on track mode so it can track us around the community, and the community gets a great view from a different viewpoint. It really helps them understand kind of the larger planning scale issues when they can see from a different vantage point. And so, here we are hanging up over the train stations right down here in Musquodoboit near the village core. But you start to see tracts of land that are open. You start to see potential road connections that maybe should be made because we've got a really unsafe condition here, and new infill opportunities, all the sorts of things that you want the community to be able to talk about. You can actually do it in real time with these drones. So these new drones have machine vision on them, so this idea of machine learning where computers are actually starting to learn algorithms, and in this case it's the machine learning is actually built right into the drone, so it can recognize people and it can follow them around. So all you have to do is track it on somebody and it will follow you as you walk around a community. The other interesting aspects, last week we were in Sydney working on a downtown plan, and we're actually using the drones to do the parking studies. So we're doing parking counts. You can set the drone on a path and it will fly that same path over and over. It'll take photos from the exact same location so that we can start at, say, 9 in the morning, go every hour, send the drone up on a reconnaissance mission. And what we're looking into is right now we would have to pull each of these images into Photoshop, do manual counts of parking, and we also look at the turnover in parking spaces. But we're looking into machine vision algorithms so that we can use a program like Microsoft Azure. Google has their own machine learning algorithms, and what you do is you teach the machine what a parking space is and what a car is, so that the machine then can take an image like this and go, okay, there's 150 parking spaces in this image, 80% of them are used up, and then you do that over time and it gives you the turnover. So it's kind of a really neat tool for parking. So the other piece of the machine learning is this is a MyoVision setup. So this is Roger in our office. We set these up on the street corners, and it will look at the traffic at the street corner, full on, creates video, does it over time. Once you're done, you take that video, you upload it to the MyoVision website. You go on to a Google Earth that's built right into it, and you tell them what intersection that is, how many, whether left turn, right turn, straight through, all that, and then it generates all of the traffic data for that intersection. The cool part about this is that it distinguishes between cars, trucks, bicycles, people. It does counts for everything. So if you're looking at kind of a downtown pedestrian count, you can use these machine learning algorithms and tools. So this is just a telescopic end. It kind of rises up about 25 feet in the air and just films it. You've got a little station here. End the video, take it home, upload it, and you're kind of off to the races. About 2 days later, you get all your parking counts in it.
Rob, how do you deal with or manage security of that bit of equipment?
Yeah, after this, let me just go back here. So there's straps that are built onto here, and it's just chained there. If somebody wanted to come and hack that thing off with a hacksaw,
yeah.
they could do it, but they would be on camera as well. So when we were doing the Argyle Street, we put that up on Argyle Street to do some traffic counts. I mean, you get the data back from 2 a.m., brawls, fights. There's people that come over and jiggle the thing.
Really?
Yeah, yeah. So it's all, but nobody stole it yet. So.
Okay, a little bit of entertainment there.
Yeah, yeah. The other things that the drones are capable of doing, you can swap out the regular camera on them for NDVI cameras. So that's, it reads the different spectral range, so you can you can start to pick up parking lots, asphalt surfaces, and just different vegetative vigor. So it gives you an index of how well your street trees are doing or how well your parks are doing. And in New York, it's interesting, they've I think I've got it coming up on the next slide. Also the infrared cameras. So I've got one of these. We use it out on different sites we're doing stream temperature modeling and being able to monitor environmental conditions. Works really well, except last week it broke, so I had to send it back, or I would have brought it with me here today. They're pretty useful. Anemometers as well. So when you're doing, say, a wind study, we'll go out to a site. You can go around various locations. You just pop this in. It gives you the GPS location, gives you the wind speed. So I could walk around kind of Queen Square here and get a sense of all the different wind speeds. And that information is used in a program. This is Autodesk Flow. So, and this is the Commons building. So there was some problems with wind around that building after it was built. We were able to pull it in to Flow, run some simulations on it. You can see low pressure, high pressure areas of the building, and we can do slices through the building. They were having a problem with wind actually blowing through the space between the building. So you can see in Flow, the red indicates the higher wind speeds, the blue is the lower wind speeds. You can see how when the wind comes from a certain direction, it really focuses it into an area in there, and you can see that really quite well. Now, this isn't a replacement yet for the full-on flume studies, but it does help to create a little bit more accuracy with regard to the desktop studies. So when you take this, you calibrate it with your anemometer and get the actual wind speeds. This gives you a great relative tool, but not an absolute value tool. So with an anemometer, you get much closer to actual wind speeds. And so you can do that on larger scale as well too. It does have some problems. You have to upload this online, and then it generates the simulations. You have to have a really fast computer to run these simulations. So this is for Spring Garden West, and we're looking at the impacts kind of between the two buildings and around, and actually playing with the different forms of the building to see if it would reduce wind in and around the blocks around it. As well, once you've got this information in, say, SketchUp, you can also run solar studies really quite easily. So what you do is you position your building in real space in SketchUp. You run the simulation for winter, summer, solstice, and the equinox seasons, and then you just see, the sun comes up here in the east in the morning. You can see these long shadows, and the white lines represent where the building shadow is going to hit at various hours of the day. If you pull all these images together in Photoshop, just overlay them one over the other. In this case, when we're in the middle of the summer, you've got about 14 hours of sunlight. You set the transparency of each layer at 100 divided by the 14, so that when you add them all up, you get black in areas where it's in complete darkness. And then you apply a filter in Photoshop, and you get these blue areas. So these are areas that are in the shade 14 hours of the day, whereas the yellow areas are getting full-on sunlight. So it's really quite an easy process. And that has real applications. So we're working, this is the Solar Carve building on the High Line. This is the New York Times building. We've got about 5 projects on the High Line that we're actually doing these microclimatic studies to look at the impact on people. So how can we improve spaces so that they're much better for people. The other application here, the Pix4D photogrammetry. So what it's doing is it's taking a drone, it sends the drone on a pre-programmed flight of either an object or a landscape, and it can create a full-on base map from that, pretty much almost in real time. So the drone flies out, flying on a mission, you upload it, and then it creates a base map. But what it also does is it uses photogrammetry, and it takes the pictures from different angles and creates a full 3D model of it. So it's not as accurate as the new ground-based LiDAR stuff, but in terms of relatively cheap, for I think it's about $80 a month is the subscription price, you're able to generate 3D models out of this software. And it can be used for some pretty interesting applications. You can measure things in it. I can measure distances, the height of trees, topography. You can generate tin models and contour maps from this technology. And it kind of gives you something that you can use as a designer. You're able to pull this into, say, Civil 3D and generate topographic maps, do cut and fill analysis, do river and floodplain mapping, all that sort of stuff, all with just a simple $1,700 drone. So you can see the next evolution is drone-based LiDAR. And so HRM's got great LiDAR for most of the municipality. It was flown at great expense a number of years ago, but the technology to put LiDAR into drones is it's out now. It's just a little bit expensive. They're anywhere from $20,000 to $30,000 for these new LiDAR-based drones. But in the next 2 to 3 years, you're going to be able, for a couple of grand, pick up a drone that can actually scan the land, and that gives us great information and great design tools. So LiDAR is being used for all kinds of things. It's really the brain behind most of the autonomous vehicle movement. But Google and Apple are both working on applications that are going to fit in your next cell phone. So Google's working on Project Tango. Lenovo has just come out with the very first smartphone with LiDAR built into it. So I could literally scan this room, scan all you people, be able to take that into software, measure distances, do volume calculations very easily. And there's rumors that the next iPhone 8 that comes out in September will have this technology built into it as well. So it starts to get really interesting for the planning applications. And of course, once you've got LiDAR, SketchUp is working on being able to import LiDAR cloud meshes directly into SketchUp so that you're able to create, it takes about 1 million points out and just creates simple surfaces from the data set. One of the other really interesting applications, the new satellite technology. If any of you have seen the recent, I think it's called Vikings on Earth, the new NOVA program, there's a whole new field called space archaeology, and they're actually using satellite systems to be able to do archaeology on the ground. With the technology, they can see through about 1 meter of ground, so they can start to pick up surfaces from space. And they've been able to use it to find ancient Mayan sites, all kinds of stuff in the Middle East that they didn't know was there. You can see right through the ground, and you start to pick up features that you don't see with traditional. So this technology is being used to look for new Viking sites all along the east coast here. So the NOVA program goes into some detail about kind of the Lanza Meadow site that was found in the late 60s. One of the interesting things they found at the site was a butternut nut, and they don't exist in Europe. The only place they exist is along the coast of New Brunswick and in Ontario and some of the southern parts of Nova Scotia. So when they found that, they surmised that the Vikings must have come down the coast a little bit further, and all of the writings suggest that they came into Vinland. They haven't been able to find it up until recently. So part of the program was looking at this new site, Point Roisey, Newfoundland, where they use this technology. They think they might have found something underground, so they started the archaeological digs over the summer, and it's all part of the program. And we'll find out next year whether, this is Sarah Parkeck, she's written a really great book on space archaeology. So it has really interesting applications in rural areas, places like Lunenburg, to be able to find stuff that you didn't know exist. So some of the urban visualization tools, I thought I'd spend a few minutes on how that's really advancing and show you a couple of examples of how it's being used. This is Bridgewater. We worked on a plan for Bridgewater back in 2012, kind of a community master plan. And one of the things that when we started, I'm sure most of you recognize when you're working on downtown plans, the retailers quite often will say, if we only had more parking, that would solve all of our problems. And of course, in smaller communities like Bridgewater, that exists in spades, so Summerside, Bridgewater, you know, they were looking for more parking in the downtown as a solution to the urban design problem. But what we were able to do, you know, using some of the drones, do the parking counts, do the turnover, suggest some areas where we could fit in a little bit more parking. But one of the big ideas out of the plan was that there's a movement towards getting a lot more people moving downtown. So it's not just Halifax. The smaller areas are looking at that as a vehicle to reinvigorate their downtowns. So one of the things that we needed, if we're going to get more people living in the downtown, is we needed better parks, better connections to the open space. When you're on the main street, you don't even see the river here because of these two parking garages that they built out over the river. And so here's one of these parking garages. Here's King Street. The river is just down, hanging down here. And so one of the ideas out of the plan was, what if we took and got rid of this parking structure and reconnected the main street back to the riverfront, created a new park. And so we started to, let me just see if that, I had a little, no, it's not going to work. We used an animation to be able to design this and fly through this proposed new environment. This was last week. They opened up the street after 5 months of construction. They've got this, they wanted to be able to drive down on here, pull boats in and out of the water, new docking facilities, kind of a throwback to the old parking garage that was there, a new look-off, interpretive panels, glass structures, these little seating nodes, landscaped area. So an area where events can happen on the river. And the overall hope is that, you know, yes, we've lost whatever it is, 70 parking spaces, but we're hoping we've created some new ones on the street. And if you'll notice here, this will be the first in Atlantic Canada where you're actually back into the space. So it's fairly common in Ontario and the older main streets. You drive up, back in the space, and then you drive away. They've been proven to be quite a bit safer. But this will be the first time we've actually tested that theory in Nova Scotia. And so just kind of a view of kind of how the thing's coming together. They've still got about another 3 weeks of construction left to go. And some of the streetscape features.
Was that ramp for cars?
Yeah, it's for people, but they wanted it to be structurally sound enough to be able to drive a maintenance vehicle down and pick up the boat docks and that sort of thing. So yeah, that added about $200,000 to what could have been a wooden boardwalk down. But It's interesting. One of the features here is that in the initial video before we started the working drawings for this project, we had kind of a wall that went down to the river, and council bought into that idea of the wall. We pulled it out in the working drawing phase in order to save a couple $100,000 of cost. But when they saw the working drawings, they wanted it back in again, so we had to add it back in. So it just goes to show you the power that some of the visualization technology can have when you're using it for things. So we've used it as well for Argyle, and Argyle will be tendered probably in the next couple of months, as many of you know. We use ground-based LiDAR. We scanned all of the buildings in 3D. We pulled them in, created a point cloud, and then pulled that into SketchUp, and then used that to create the base models for all the existing buildings. So all of this modeling was done in SketchUp. Once we were finished, we pulled it into Lumion, and Lumion allows us to use virtual reality. So it's quite a neat tool, and if I can get that started over here when we're done, I'll show you how some of that works. I can't seem to get the technology working here today. So, but it's interesting, once you have it in 3D, the ability to sell a project, this is all real data. The only thing that's different is that we had to create a flat surface rather than sloped streets. It would have been much more time consuming to create a real terrain model from this. And so, it's neat. Over some of the building, you can see on the Nova Center side, some of the building is actually sticking up out of the ground because we haven't created the street at the same profile as the real street. So you'll notice when we hit Sackville Street here on the corner, and we try and hide it with trees and everything else, but you'll see how the building is sticking up. That's where the sidewalk actually goes in there, but it's just a way to simplify. It saves about a week of modeling time to create one flat surface. So it gives you a pretty neat effect. You can, of course, you run real shade studies on things. You can put real lights in there and test real lighting levels once you have the model built. And so this is the Grafton Street, so it's going to connect Grafton and then 2 blocks of Argyle Street. And it's a great tool for being able to test different kind of parking layouts, different paving patterns, see how the sidewalk cafes are going to work. And so it's been a really great tool as part of the kind of the process. But even on smaller communities, we use the same kind of technology. We've gone in, we've run in Summerside almost 3 years worth of public engagement sessions, workshops, community sessions, and open houses to try and get a sense of what the community would like to see. It led to an overall plan for the downtown, and if you know Summerside, the old Towers Mall is right here, and so it's in the plan. Part of the big idea is over time to convert that into a campus. It was bought by Holland College, and so the idea of reintroducing a street grid and a new urban structure, creating a new marina, so using the infill from that marina to create a new urban park that would service residents as well as the university. And then if you've ever driven downtown Summerside, it's a lot of open parking lots. So how do we start to look at infilling those sites with new development? And as well, then you're into the same tools here in Summerside, where we're able to use GIS information to just propagate flat buildings. We went into the downtown, did a little bit more detailed modeling to get some of the existing buildings, and then used buildings to be able to show how this new urban campus might look. Student housing, it's obviously a very ambitious plan. This is probably a 50-year future here, but for the downtown, it's looking at kind of 7 to 9 story buildings, mid-rise buildings, and preserving open space, all these views out to the water. So a lot of the same things that are part of the plan here have been integrated in at a smaller scale into Summerside's plan. So again, interesting. Lumion was used. Once it's done, you can pop it into VR and be able to kind of look through these landscapes, zoom in and get a detailed sense of what streetscapes look like, what the spacing of buildings might look like, how different scaled buildings feel on the street, and then that helps to inform your form-based code for the area. So in this one, we actually looked at pulling a canal into the site to create more waterfront space, and just a couple of different opportunities for different open spaces, bringing kiosks out onto the wharves and activating the wharves as part of this. New marina infills that provides marketing for these new residential properties on the waterfront. So the virtual reality stuff is really interesting. If we can get it to work, it worked when I left the office, and when I got here, my machine won't boot up, but I've got the goggles here. It's just, it's such an immersive experience. Within about a second, your brain is tricked into thinking that you're actually in the space. So to look at Argyle Strait or even the Cogswell interchange project, it's really interesting. I put some links on here. If you click on those, I'll get this presentation out to you guys. It will show you how architects and planners are starting to use these tools. And so my gloves haven't come in yet. They come in next week, but this is the Oculus Rift headset. And you can manipulate objects in 3D. So I can set a model on a table, I can start to move it around, I can draw buildings, I can push buildings back, pull buildings into the space, and see how it works. So if you click on that link, you'll see it's just some amazing tools coming out. And even Google Earth now, they've got a virtual reality version of Google Earth. So you pop on your glasses, you can manipulate the world around, you can zoom into three-dimensional cities, and it's a pretty interesting tool. So I suspect within the next 5 years, you'll probably see your desktop monitors gone, and you'll probably see tools like this, because they've got virtual desktops where you can open up several spreadsheets around you. I can be looking at one spreadsheet and turn around and look at another spreadsheet or a GIS application, and you can have all kinds of things open. It opens all kinds of possibilities. So the VR applications are coming to a lot of commercial software applications. So SketchUp is now starting to work on a VR tool. Autodesk has a bunch of their BIM software is starting to integrate it. And there's some kind of intermediate steps that are easier. So Lumion is one application. You go to SketchUp into Lumion, and you're able to generate static 3D waypoints. So it's fully 3D, fully immersive, but you can't walk around in these spaces. You're stuck. All you can do is kind of look around. There's other tools that are becoming easier for planners and designers to use that allow you fully navigable animated models. So I could put Argyle Street in, I could walk around within Argyle Street, I could have people walking by, birds flying by, all those sorts of tools. And so it's starting to use the gaming engines. So Unreal Engine and the CryEngine are two free gaming engine tools, and they're starting to make it easier to interface with existing design tools so that you can get them in and create these virtual environments. The next step from virtual reality is augmented reality. And so this is the Microsoft HoloLens. It's now in development mode. It's about a couple of grand for one of these headsets. And the difference is with augmented reality is you can see the room around you, but I could place a building on that chair and I could move it around. I could zoom right in to the unit. So it allows you to interact with holograms in a virtual space. So it's a little bit different. Again, if you watch this link, it shows how some architects are using it to collaborate on new buildings. Really sort of an interesting tool. And that's going to be probably another 2 years before that comes out. It'll probably be somewhere in the $600 to $800 range for the headset, and the developer tools are getting easier and easier to use. Microsoft's latest product launch, their new Windows 10 3D and HoloLens and all their new computers that they launched about 2 weeks ago, they're building these features right into the operating system to be able to allow you to interact with augmented models. The big one, and I thought I would save some time at the end for discussion, the whole autonomous vehicles thing, and it's really interesting if you chat with people, even people in the know, you know, when is this technology going to come along, how long is it going to take before it's mainstream. I was able to, through one of the grants through API, go to the conference in Toronto this year, the autonomous vehicle. And it's interesting, there's only probably 3 planners there, most of them from Toronto. The rest of them were the insurance industry, the trucking industry, everybody that's afraid to lose their job when autonomous vehicles come were there. But not a whole lot of policymakers, and I think it's going to have a huge impact on planning in the same way that when we went from horse and buggies into vehicles, it's going to have that scale, and it's going to come much faster than we think. So I've got, at the end of the presentation, I put these all on Dropbox, and I put a link to it on if you guys want to download the presentations from that conference. I took a few snippets from some of the presentations because I think it paints a really interesting picture of where things are going. So first of all, the first wave is already here. We've already got semi-autonomous vehicles that can do lane changing, autonomous parking. Tesla's come out with their nearly fully autonomous vehicles. There's trials of in the UK of parking and cabs. The heavy industry's already moved to these. So you know, these giant heavy haulers, half their fleet have moved to fully autonomous. There's no people in these things. And so in terms of the timeline for them, we're already seeing the first gen out. Most of the automakers are talking about somewhere around 2020 to 2022 for the first vehicles. So it's coming much faster than, so we're 5 years out, and yet we're planning transit, we're spending billions of dollars on things when this technology has the chance to really change things, and in particular our downtowns, how parking works. And I'm going to show you some of the interesting stats that came out of this. So by 2025, there's going to be fairly significant usage. And I'll tell you why in a second. But you know, when you look at the penetration, here's 1900 in New York City, no cars. Just a couple of years later, vehicles come on stream. Here's a shot in 1913. So 13 years later, the transition from, you know, it will happen that quickly. And so Uber is moving into this, so the shared space where, you know, they've got these Uber pools where carpooling took 7.9 million miles off LA roads and 1,400 metric tons of CO2 in its first 8 months. So one small city and what it's doing. And so the potential for you to be able to not really have to own a car in the future. You know, if I want a car here, it can pick me up. If I wanted to drive me downtown Halifax with just me in the vehicle, I'm paying one price. If I wanted to stop along the way and pick up several other people, it's going to be cheaper to do that. And you know, some of the moves here is we've got this savings per year, the statements that one AV replaces 2 to 13 private vehicles. We've got, you know, the overall idea is that we're putting more people, it's like transit. Think of a smaller form of transit, but it's personalized. It can pick you up, it can take you to work, it can take you to the grocery store, but it doesn't have to park and wait for you, because you know there's just a network of these things running around. And so it frees up parking space. And they've talked about who wouldn't want a personal chauffeur. So they're actually looking at in Singapore, Helsinki, LA, at AV zones in the downtown. So in much the same way that we have, you pay fares to get into the downtown in London, they're looking at AV only. So you can only have autonomous vehicles, and that's the idea of getting car share going, getting things so that we're getting less cars on the roads in our downtowns, and we're able to turn over the real estate that's now being locked up by parking lots. But it does mean that we also have to look at, well, cars are going to be dropping us off. So what happens to the on-street parking? A lot of that may convert over to drop-off zones in the downtown. So we have to start thinking, we're 5 years out, what's that going to do to how we configure our streets in downtown? So really it gets back to this idea that the estimates are somewhere around an 80% reduction in collisions. There's still 7% of the collisions that are non-driver that are going to happen whether you're driving the car or whether a computer's driving the car. But that's going to have significant implications on the insurance industry, on policing, on fire, on even surgeons, the amount of surgeons. So it's going to have a cascade effect on the whole economy, and things will change very quickly. So this idea of transportation as a service, the idea that through your smartphone you have mobility as a service, and you really have personalized mass transit, so it changes the transit dynamic quite a bit. And so in Toronto during this conference, the Transit Authority was there, and they've got plans in the hopper for billion-dollar transit-oriented developments that they're now starting to think, wow, what are the implications of this if we start to invest now? By the time it's built, this technology is going to overtake what we've invested in. Of course, it changes where people live and work, so it changes the design of homes and how you set up. You don't need garages, but you need areas, pickup areas. So the overall thrust is that hopefully it creates less parking space, less pollution. So these are all kind of the panacea. It will be interesting to see what really plays out at the end of the day. But we're certainly going to see AV-only zones, and if you've been listening to the radio this week, Ontario's the only place in Canada that is actually doing the testing. So BlackBerry, some of the universities, and industry are all coming together. So they've got their first 3 prototypes that are now driving on the roads in Ontario. And it would be neat to think that Nova Scotia could be a player in this and start to, we're small enough, we don't have the same traffic levels. It would be neat to think that we could dip our toes into this sooner rather than later. So some of what Helsinki's doing, really interesting, providing an array of options for cheap, flexible, well-coordinated, becomes competitive private car ownership. So lots of interesting things coming up on it, and I think you'll find the presentations in there are really interesting read. But the transportation as a service, so it's just a whole new way, the way Uber works, where you can call up cars, is going to be playing a much major role in the shared economy. And we could see, this is from the Department of Transportation here in Ontario, a change from, in Ontario, 2.18 million private vehicles down to 0.85 million vehicles if it's strongly adopted. And so, there was a lot of questions here, the autonomous vehicle people that believe in this stuff, starting to ask questions that only planners can start to answer. How do we repurpose parking spaces? How do we take advantage of these, and how do we look at these for new transit solutions? And so they're launching in Germany and other locations much smaller transit where you can only fit 6 people on these vehicles, and it just goes around and regularly picks you up. So we'll see all kinds of different transit solutions. And so the link should be hot when you download this. Just click on this and it'll take you to the Dropbox site. And I wanted to do one last plug. We're we've been working on this idea of self-organization theory. So in business, in consulting, how do we get teams to work together better? And we've developed an online software as a service tool to be able to collaborate much easier between teams to get projects done. And I won't get into much detail, but if you're interested, there's a link there as well. One last plug, I'm also, in my spare time, I'm a tech writer for Landscape Paysage magazine, which is the magazine of the Canadian Society of Landscape Architects, and we've got a Twitter feed at landtechcanada.ca, and it's kind of deliberate how it sounds, a little plug for Atlantic Canada, but if you go to that in Twitter, there's all kinds of, and it's almost all planning related technology, so all of these things, you'll just find really interesting links to some of these new emerging technologies. So that's it. I don't know how I'm doing for time, but I thought there's probably enough there that we could have a discussion.